Hello, welcome to your final video for bridging. You'll all be relieved to hear this is about the features of science. So these are things that you will have to apply. A debate we used to look at that we don't anymore, but that can still be seen throughout psychology on the spec is psychology a science? And these are some of the features of science, and we have to debate whether they are, so we can use those to kind of discuss whether the psychology is being delivered scientifically, whether it is a scientific subject. So if you look at that example that I gave in the booklet about energy drinks, hopefully you've already made some notes on it. If not, pause the video now, make some notes because it's through the to-do list, and then you can add some more as we go along, thinking about the different key terms. What would we say? But think about, first of all, start off by essentially just evaluating it in general. Tell me about the sample, the method, the way it's conducted. Is there anything that you can see and consider that we could talk about? And then from that you can apply the terminology. So there are lots of questions if they ask about the features of science. It's just how do you conduct research scientifically, and it's basic evaluation. So tell me about the strengths of a lab, the weaknesses of a lab, so on, different things like that, whatever it might be. Okay, so just evaluate my study. Is it good? Is it a good study? Is it not? Why not? Okay. Then we're going to look at so some of the features of science. First one, empirical methods, and this is really, really important for the scenario that where I have to prepare for ASHA. So empirical methods, empirical is, I think it's Latin for the word evidence, and we've talked about that, haven't we, when we talked about empirical disputing and evidence. Empirical methods are, have we collected the data through direct observation and experimentation? So direct experience. Empirical methods is talking about our experiences. So empirical experience. So and the most empirical methods, the one where we can be the most confident, direct observation of what's happening, is experiments and observations, because of course we're directly observing it. It's not relying on retrospective data like a case study, tell me about this and what happened, but also we can be confident because we can be confident of cause and effect. So we in empirical methods where we're in control, we can change something and then see what the resulting behaviour is, so cause and effect, and that's an empirical method because we've directly observed it. Objectivity, we briefly touched on this in some classes. Objectivity, the opposite of subjective. So if something's subjective, it's based on opinion, it's open to bias, it's open to interpretation, it's not very scientific at all, it's very subjective. One person could one person could think another. It's very ambiguous, it's not based on empirical methods. Objectivity is free from bias, so we collect objective data, so data free from bias, by conducting the empirical methods, the most controlled methods that we can conduct without any bias in them. Okay, so it's as simple as that. If it's not subjective, shouldn't be influenced by people's opinions. So of course content analysis is quite objective, or it can be because of interpretation bias. Some observations can be subjective as well. Because of observation by interpretation bias again. So the idea that one person might have observed behaviour, and I think you would have all seen this in the Bobo doll study if you've done that in class yet, that some people, got different tallies when we did inter-observer reliability because different people understood the categories in different ways, hence training. So if something's trained and you're trained to use it, then it's objective. And if you think about Wundt and introspection, he trained his research assistants to deliver and interpret introspection in an objective way. It wasn't based on their opinions, they were carefully trained, and that's why Wundt is so significant. First one to use empirical methods, first one to conduct objective research that wasn't based on bias and opinion, unlike philosophy that didn't use empirical methods, so didn't do direct observation and was very subjective, so based on people's opinions. So instead, reliability is absolutely vital, and we're going to extend your knowledge of reliability. We're going to talk about that a lot more. You know what reliability is. If you can repeat something exactly the same way and find similar results, then it is reliable. So reliability and replicability are important in this one, so probably a better term would be considering replicability. You must be able to replicate something to check for reliability. So something that is scientific is replicable, so we can check for reliability. Can we repeat it? So of course we know that Jeannie's case study isn't, for example, any of the case studies aren't reliable because we can't replicate them. We're not allowed to lock a child in a room for another 13 years. We're not allowed to give somebody surgery, not allowed to get somebody to engineer a car crash so they have exactly the same sort of brain damage as someone else and see what happens. Whereas if you think about memory experiments, Milgram's experiment, Asher's experiment, all of those have been replicated to check for reliability. They're dead easy to do again and again and again and again to see if we can find the same results. This is really important, this next bit. If you're looking for the higher grades, when you talk about reliability, you want to take it beyond replicability and reliability. You want to talk about the idea that, and so if you're going for the higher grades, this is incredibly important. Even if you're not, it's really useful to try and understand because you might surprise yourself. Just keep trying. The idea that if we repeat something several times, we can be more confident that the results are due to cause and effect and not due to chance. If we do something once and find results, then we don't know if it's a fluke. Statistically, it could be a total fluke. We could never ever see that again in any of the research. So again, for example, Genie, if we locked 1,000 young children in rooms, we might never see the same effects we saw in Genie, but we don't know that because of that one person, so we can't be confident the results are due to cause and effect. They could be due, statistically, they could be due to chance. If we replicate them a second time and we find the same results, we can be more confident because of probability that it is less likely to be due to chance. If we replicate it 100 or 1,000 times, we can be even more confident that it's due to cause and effect. It's due to the thing that we're looking at, the IV or whatever it may be, and not due to chance, fluke. So if you think about it, the idea of flicking a coin and it lands on its side, we all know because you've flicked thousands of coins that that's total fluke and it would probably never ever happen to anyone again, as in sort of balanced on the edge as opposed to heads or tails. It's just balanced in the middle as if it's just about to roll off the table. We know that's total fluke. However, one person, if they fix a coin once in their whole life, they might think that every single coin always lands on its side like that, ready to roll off the table. And we know that's not the case because we've replicated that over and over again, and we know it's due to cause and effect. We know that we've done it several times, and it's not due to chance. So that's why reliability is so important, because of probability, ensuring that it's not a fluke. Falsification is a lovely one if you do sociology, or if you went to the TRIP, the Cara Flanagan conference, it would have been brought up as well. Somebody called Kuhn, who brought up the idea that psychological theories, or any theories, for a science to be scientific, you must be able to falsify its claims. Okay? Falsification is the idea that you can never prove a hypothesis. So this is why I've consistently said, do not use the word prove. You can never prove a hypothesis. However, you can disprove it. So I'll give you an example. The one that Kuhn used is about swans. So this is the idea that if your hypothesis was there are only white swans, then no matter how many times you went around the world searching, if all you ever found was white swans, you could never prove your hypothesis. You could just continually develop more and more. You could be more and more confident. So you just say, and if you listen carefully to the way the scientists talk, particularly say physicists or so on and so on, when they present their theories, they say we can be pretty confident. We can be very, very confident, but they never say we are 100% positive. We have proved this. It is not possible to prove anything, and we must always bear in mind it's not possible to prove anything, but it's always possible to disprove it. So we must be open to that concept of disproving our theories and developing them, because that's how we develop as a science. But anyway, back to the white swans. No matter how many times you go around the world, you could see 33 billion white swans. That just confirms your confidence in your hypothesis. It doesn't prove it, you're just very confident. However, one single black swan can disprove your hypothesis. You must change your theory, you must change your hypothesis to incorporate that. So your hypothesis would be almost all swans are white and some are black. And then you need to, so with some rare black swans, and then you'd need to continue that, and then you would need to continue to research that hypothesis. So falsification, and there are lots of theories we're going to look at. So for example, Freud next year, there are lots of theories that you can't, it's not able to falsify them. You cannot conduct objective empirical research on it to check for reliability, so you cannot falsify. For example, Freud says everything happens in the unconscious. We cannot measure the unconscious, therefore we cannot collect data to see if it's possible to disprove it. So of course we may never find evidence to disprove it, so we can develop more and more confidence in the hypothesis, but we have to be able to search. So as scientists we should be able to have a list of things that we think, oh, if I find this, this and this would disprove my hypothesis completely. So I must seek those out and be able to check. And the idea is, hopefully, if your theory is good, you'll be able to check each one of those off the list. Nope, that doesn't, I've researched that, and that isn't something that disproves my hypothesis, so I can develop a little bit more confidence in my theory. Next one, I need to do some research on this. No, that also doesn't disprove my hypothesis, so I can continue to be confident. Oh, that one does, right, I need to develop and change my hypothesis, my theory in some way. The best example would be, and that's key, that's why you always seek out evidence to disprove it, and then if you don't find that, you can develop more confidence. The best example is, I saw a argument, this is the example I used with the A2s at the start of the year. I saw an argument on Facebook, shockingly, about dogs and whether they are carnivores, or whether they can they can survive without meat. So if they can live a plant-based diet. And one woman was arguing very strongly that dogs can be carnivore, that they are carnivores, they have to eat only meat, and that is it. She went on Google and she typed in, dogs are carnivores, and then the first answer, of course, that came up was, so that was what she searched, and of course what came up was hundreds and hundreds of things to support her hypothesis that dogs are carnivores, and she screenshotted it and sent it, and it didn't mean anything at all. She'd sought out information to support her hypothesis. You should never do that. You should seek out information to disprove it, and if it doesn't disprove it, then you can be more confident in your hypothesis. So if it was me trying to make that point, I would Google dogs that don't eat meat, and you would find that the oldest dog in the world is one of the recorded oldest dogs in the world is plant-based. Well, it's dead now, but was plant-based. Therefore, not offering support for her hypothesis. So if she was a good scientist, she would then develop her hypothesis to include that information that disproved her hypothesis. All dogs are carnivores, so you'd have to develop it, she'd have to research it a little bit further as well, and that is the backbone of science. We must always be prepared to develop and move science forward by accepting that we aren't right all of the time and changing our hypothesis. And this is where theory construction comes in. And this is on in the textbook, so I want you to have a quick look at the difference between inductive and deductive theory construction. But it's vital you either start with a hypothesis and you test it, and from that you develop a theory depending from your findings, or the other way around. So you have a theory and then you test it with a hypothesis, and then you refine that theory. So it's exactly what we're talking about with the process of falsification, is really embedded within that. You must have theories. So theories are general laws, and then we must construct those so that we can refine them, develop them, use them, test them. So it's absolutely vital that you develop theories that can be tested, which is why Freud isn't a great scientist. Very revolutionary man, but not a great scientist, because he didn't develop theories. He developed theories that couldn't be tested, which therefore didn't allow him to refine them and consider them. Okay? And hypothesis testing, so theory construction, hypothesis testing, very similar things. So hypothesis testing is where you must have a hypothesis that you can test, and falsification comes into this one as well, because it's a thread throughout the whole of psychology and through all sciences. So with hypothesis testing, we must always accept, start off with the null hypothesis, and this works with the idea of falsification. We must always accept that there is a chance to that we are wrong, and then only with enough evidence can we accept that we'd be more confident of that. So we always start off with a null hypothesis, so there'll be no difference between this, this and this. We then test it empirically and objectively and possibly replicate it so we can be sure of reliability. So we're falsifying it. If we don't find any evidence to support that null hypothesis, then we must accept the alternative. We can consider accepting the alternative, and which suggests we can be more confident in the theory. Okay. So, but the key thing with theory construction and hypothesis testing, we construct theories that allow us to test hypotheses, which is absolutely vital, so we can falsify our findings. And paradigm shifts. Paradigms are things which science accepts, and which they sort of themes running throughout that all scientists within that almost all within that area of learning accept paradigms. So, for example, in physics, it's string theory is an accepted paradigm. I'm trying to think. An example would be that in astrophysics, it's accepting that the world is round. There are certain paradigms that we all accept. In psychology, the original paradigm that all psychologists started off kind of accepting, the general theory or law that ran throughout everything that we tested within psychology, was behaviourism. So the idea that behaviours are learned, that we learn them from our environment. So you've got Skinner, you've got Pavlov, got Bandura. So think about the first kind of, I say psychology was developed around the turn of the century, ever so slightly before. The first 60 years of psychology was the paradigm, the belief, the firmly held belief by almost all psychologists was that behaviourism is key to our learning, that we learn from the environment. Paradigm shifts come when we shift our paradigm, we change our understanding, and we move in a different way as a science. So shifting from the idea that the world was flat to shifting to the paradigm the world was flat, which everyone accepted, to shifting the paradigm towards the idea the world isn't flat, it's round. The same with psychology. We moved from behaviourism, we shifted that paradigm, that belief that ran through the whole of psychology, a bit like if you get a rock from Blackpool, you cut it open, it says Blackpool or whatever down the middle. The same thing, if you cut psychology open, there would be the idea of behaviourism, the fact that everything's learnt, and it's all about observable behaviour. And then we shifted our paradigm, so a lot more psychologists now accept that cognitive psychology is the paradigm, is what we base everything on. The idea of internal mental processes are absolutely vital, and you know all about those. So we change the view, we shift things. So it's really significant research that shifts paradigms and changes the way that we view things as well. And this is why Kuhn argued, I think it was Kuhn, that psychology isn't a science, which of course is not the case. No, so he argues that psychology isn't a science because we don't have the behaviourism and cognitive psychology is a general paradigm, a paradigm that was shifted to another paradigm. However, generally we have a lot of psychologists that don't necessarily agree with one particular paradigm. So we do have cognitive psychologists, but we still have behavioural psychologists, we have biological psychologists, have a huge range. So the fact that we have so many differing views means that we potentially aren't a science because of we lack a significant paradigm that kind of binds us all together. And of course, if you go through, you can see there's loads of elements of psychology that don't actually fit with the features of science. If you go back over those, if you return to my example of Asher, you can see, ask yourself, is there any empirical methods used? Am I being objective? Am I being subjective? Is there an opportunity, or has there been an opportunity for reliability and replication? Am I accepting the opportunity for falsification? Have I developed a theory? Can I test that theory? Have I developed a hypothesis? Paradigm shifts, perhaps a bit more tricky to use there, but that's what you can consider. So of course there are elements of psychology which are very, very scientific, but there are also elements of psychology which aren't, which is why sometimes it's difficult to consider psychology as science, because there's such a broad range of views and research and areas we look at. Okay, there we go. Right, hopefully you've been able to make the final notes for bridging on your homework. Any questions at all, please get in touch with me. Please email me. Do not leave any gaps or anything you are not sure of for your session on Thursday or Friday. Lovely. Thank you very much.